It's 8 a.m. in the morning. You get up on a beautiful summer day in Hawaii. You walk downstairs to pour yourself a steaming hot cup of coffee, and you add a little bit of maple syrup to it because you watch The Science Behind That podcast. On your way out the door, you grab your surfboard and your earbuds to listen to the latest episode. When you get to the beach, you notice distant storm clouds on the horizon. Storm clouds that look dark and angry. So you turn on your weather radio, and you hear a report about a hurricane that is quickly approaching the island. But how do they actually know that a hurricane is approaching the island? Let's talk about the science behind that.
Welcome to The Science Behind That with Atticus Hamilton.
Hello everybody, and welcome back to The Science Behind That. Welcome all you scientists out there, and before we get started today, I would just like to thank every single one of you out there listening to my podcast. In the span of less than a week, you guys brought my podcast up from 200 downloads or 200 plays to 257 plays. So I'd just like to thank all of you. It is growing faster and faster with each one of you that listen to my episodes, and I'd like to thank you because it is all because of you guys out there that I can bring you this podcast, and that because of the people right now who are listening to this episode, more people will eventually hear it, because the more of you that listen to it, the more Spotify and Google and Apple will recommend it to other curious scientists out there about the science behind everyday life. So with that said, it's time to get into today's episode. As you already heard from the intro, you need to grab yourself a steaming hot cup of coffee and some maple syrup before we can get started. So today, we're talking about weather. But before we can understand how meteorologists, or the scientists that predict the weather, are able to predict the weather, we need to understand two types of what are called pressure systems. So in meteorology, the global air currents are studied in depth of the planet, along with global ocean circulation. And the air currents of the planet can change what the weather is like in a specific region. So there are two different types of pressure systems. There's what is called a low pressure system, and there's what's called a high pressure system. And so a low pressure system has, well, obviously lower pressure at the center than the surrounding environment. So the center of this pressure system, the atmospheric pressure is much lower than you would expect normally. And winds, because of that, winds blow towards the center of that low pressure system. And this is in contrast to a high pressure system, where in the center of that almost cyclone, you could think of it as like a wind cyclone, you have air that's coming down, and you have a much higher pressure in that center area. And so because of that, all the surrounding air is pushed out. And so what does that mean for weather? What that means is high pressure systems, because all the surrounding air is being pushed away, they typically bring fairer weather and light winds, because it's essentially a large spinning cyclone of cold, dry air. And so, I don't know if you guys have ever been to like Arizona, but if you've ever been to Arizona in midsummer, where there's not a cloud in the sky, there's no rain anywhere, and it's just hot, that is a high pressure system that's around that area. And then a low pressure is a low pressure system is when it essentially brings the storms. So just last week where I live, we had a huge storm that brought like 2 feet of snow to Colorado, and that was a low pressure system. And the reason that is because with low pressure systems, it's air from the surrounding environment that's brought into the center of that low pressure system. And so because of that, you have very dense clouds with a lot of moisture bringing precipitation to a particular region. And so now that we understand the basic pressure systems, now we can begin to understand how weather prediction works. And so starting off, meteorologists can use what is called Doppler radar. And I'm sure every single one of you out there has heard the word Doppler or the phrase Doppler radar before at some point or another. Meteorologists use it all the time to describe big storms. And on the Doppler radar, we see Hurricane Sandy barreling towards Florida or whatnot. But what actually is Doppler radar? Well, Doppler radar, they are essentially large radio towers that are able to detect all types of precipitation and the rotations of thunderstorms across the United States. So Doppler radar is essentially a lower wavelength radio wave, essentially. It's a lower wavelength frequency that is emitted from a large tower, and because it's lower wavelength, it has higher energy. And so it's able to travel great distances and bounce back off of storm clouds and relay information back to that tower about what is the composition of that storm cloud. And the United States has several of those across the country, and they provide a lot of the data about neighboring storm systems. And just like with everything we'll discuss today, all of that radar data is fed into a computer system that's called an AWIP, or an Advanced Weather Information Processing System, that will use all that data to create a prediction on what the weather will be. Additionally, satellite data is often used as well. And so I think we all know what satellites are, but when somebody says, well, satellites monitor weather, what exactly are they doing? Well, satellites have numerous sensors on them. Satellites are able to detect changes in sea elevation by just a few centimeters to tell us what's on the bottom of the ocean. Not only that, but they can tell what the composition of clouds are in the atmosphere. And so the way the weather satellites work is as they rotate around the Earth, they take detailed images of the Earth every day, and some of them can take pictures of the Earth every 30 seconds, and they relay that information back to a particular country's weather service. In the case of the United States, it's going to be NOAA. They relay that information back to NOAA. And along with taking pictures, they're able to analyze cloud data and determine the composition. So is it primarily warm systems? Is it a high pressure system? Or is it a low pressure system? Which directions are the winds moving? And that tells the researchers information about how those low pressure or high pressure systems are moving across the planet in what's called the jet stream. And the jet stream is just a large stream of wind in the upper atmosphere that moves across the entire planet. The other devices that weather predictors use, meteorologists use, are called radio sounds. And what radio sounds are they're instruments that connect data in the upper atmosphere on air pressure, temperature, humidity, wind speed, and wind direction. And they're attached to weather balloons, which are just large balloons that propel the device up into the upper atmosphere. And in the upper atmosphere, that radio sound is going to sample the atmospheric environment. And it's going to relay that information, the air pressure, the temperature, the relative humidity, the wind speed, wind direction. It's going to relay all that information again back to NOAA, or back to whatever country we're looking at, back to their weather predicting services. And it's going to feed back in to those AWIPs or IPSs, and though that computer program is then going to create an algorithm to determine what the weather is most likely going to be. Additionally, at least in the US, meteorologists use automated surface observing systems, or ASOS systems, which is just a fancy term for a ground-based weather station. And what those do is they monitor the surface visibility, any precipitation that might be there, temperature, and wind speeds. And that information, again, is relayed back to a supercomputer. And ultimately, these computing stations incorporate all of the data that was taken by those previous instruments and create a model. And so the program is able to say, well, there's a low pressure system over here east of the US in the Atlantic, but the wind in that region is moving very strongly across to the west. So that's going to push that low pressure system over to the Atlantic. And then additionally with the radio sounds, which collects data around the temperature, the program can also say, well, once it gets into South Carolina or the coast of South Carolina, the heat, because it's summer there, the heat is going to cause increased evaporation, and we may see a large rainstorm, which may progress into snow as it gets into the interior of the United States. And so basically the supercomputing uses that data, it combines it all, and comes up with forecast models, which are then compressed into advanced weather information processing systems, which determine global weather for the entire planet or for the US based on the data that was taken by all those above methods and sampled. And this program will then use that raw data and create graphics and hazardous weather watches and warnings to be sent to the civilians of the country that we're looking at, that we're studying. In this case, again, the US. So generally, that's how weather prediction works. Meteorology is it's like a mix of computer science and planetary science and chemistry, because the satellites are analyzing the atmospheric chemistry and the wavelengths of light reflected back to their sensors, and the radio sounds are determining temperature and, again, atmospheric chemistry. But then the ground-based weather stations are monitoring the ground environment and then using computing to compile it all into one prediction. So it's a really interesting field, but that is how weather is predicted. And that also explains why, meteorologists are frequently wrong, because again, that's all it is. It's just a prediction. It's not an exact science, because it's just using all the available data to come up with essentially a hypothesis of what the weather is going to be like. So, ladies and gentlemen, I hope you enjoyed today's episode of The Science Behind That. I had a fun time making it. Thank you again to all of you out there, all of you old listeners and all of you new listeners. Thank you for listening to my podcast. I hope you enjoyed it. And ladies and gentlemen, as always, have a lovely Friday, and I will see you in the next one. Remember, stand up and question everything.